Hello, Matthews, Gatos here. In this lesson, chapter 5, lesson number 5, we will be looking at combining the laws of logarithms. So I just want to begin by reviewing the laws that we've already done. So in the last lesson, we looked at the product law. The product law stated that if we have two logs that are added together, we can combine them as one log by multiplying the arguments. The other way is also true. If you have arguments that are multiplied, you can separate those into two different logs that are added. We had the quotient law. The quotient law stated if you have two logs that are subtracted, they can be combined together as one log by dividing the arguments. The reverse is true. If you divide the arguments, you can separate them into two logs by subtracting. And lastly, we looked at the power law. The power law states if you have an argument that has an exponent of n, you can bring that exponent down and multiply it by the log. Also, if you have a number in front of the log, you can bring it back up to be an exponent. So we're going to look at how we can put those laws together in one question. So let's see this one here. We have three different student work to the question 4 log base x of 2 minus log base x of 8. They want to write it as a single log. So let's go through and examine all of their work. So let's look at Shane's work. So what Shane did is he sees that they all have a log base x, and he sees this is a 2. He tries to write the 8 as a power of 2. Well, 8 is 2 cubed. So that step's good. Then what he does is he brings this exponent down using the power law and writes it out in front. That's good. Now we can add by common terms. We have 4 log base x of 2's, and we take away 3 log base x of 2's, and we end up with 1 log base x of 2. So that looks good. Let's look at Emma's work. So Shane, correct. Emma's work. So for her, she takes the number in front and brings it up as an exponent. So 2 exponent 4. That's good. Then she says that 2 exponent 4 is 16 minus log base x of 8. That's good. And then it looks like what she did is she subtracted the arguments. So she said log base x of 16, take away log base x of 8 is just log base x of 8. So she subtracted the arguments, and that is incorrect. She should have divided the arguments. So Emma is wrong. Let's look what Clayton did. Clayton brought the 4 up, and then he multiplied 2 and 4 together to get 8. Well, we know that that's wrong. Okay, he should have brought it up as an exponent to say that it was 16. So Clayton is wrong as well. So only one of the students is correct, and that would be Shane. Now, of course, you can look to see that Shane is actually correct. Let's look at what he did. So you can look at what he started with, and you can look at what he ended with, because they all ended with a different answer. So what he started with in y1, what he ended with in y2, and you can see for the permissible values, y1 equals y2, so we know that he is correct. So if this was a diploma question, and say it was a multiple choice question, or an exam question for that matter, we could have put all of these into the calculator. So the original question in y1, and then I put Shane, Emma, and Clayton's into y2, 3, and 4. You could just do it one at a time, and you just look to see which one matches. And the one that matches is the one that is correct. So you can see that these two match, so that's why Shane is correct. Okay? Emma's doesn't match, that's why she's wrong, and Clayton's doesn't match. His is probably the worst solution. So it's all zeros all the way down. Okay, so let's try this. We're going to write it as a single log. So here's my steps that I'm going to follow. Numbers in front go up to be exponents. Subtracting logs are combined by dividing. Adding logs are combined by multiplying, and then you just simplify. Okay, so numbers in front come up. Numbers in front come up. So I have log base a of 16 to the 1/2 minus log base a of 8 to the 1/3. Okay, let's look at what that is. 16 to the 1/2 is just the square root of 16. 8 to the 1/3 is the cube root of 8. So then I have log base 8. The square root of 16 is 4. The cube root of 8 is 2. So when I have subtracting logs, so I'm going to combine that together as one log by dividing the arguments, 4 over 2. So I end up with log base A of just 2. So I can go ahead and always check that by putting the original into y1, the answer I got into y2, and you can see that they are in fact equal. Okay, for this one here, these all have the same base, which is an invisible base of 10. So I know I can combine that. So following the same steps, numbers come up. So I have log of a, take away log of e to the exponent of 5, take away log of a squared. So subtracting logs are combined by dividing e to the 5, and then I'm dividing again by a squared. So looking at this, I have an a in the numerator and an a in the denominator, so I can simplify that a little bit more. So the e exponent 5 stays there because there's nothing I can do with it. I have one a in the numerator and two a's in the denominator, so I have more a's in the denominator. And all I have to do then is go 2 take away 1 is 1. So I end up with 1a in the denominator. And because I've canceled those, I leave a 1 as a placeholder in the numerator. So that would be my final answer. Okay, for this one here, we want to write it as a single log, and then we're going to evaluate it. So again, numbers in front come up. So I have log base 6 of 4 squared plus log base 6 of 2.25. So I'll just write 4 squared, which is 16. So I have log base 6 of 16 plus log base 6 of 2.25. Now I have adding logs can be combined by multiplying. So that would be 16 times 2.25, which is 36. So 6 to what exponent gives me 36? 6 to the exponent of 2 gives me 36. So I know that I've done that correctly. Just checking it, original expression, into the calculator, you get 2 as a final answer. Okay, over here, a little bit of a twist. So we have log base 5 of p equals 12. We want to determine the exact value of this. So since I'm given an expression for log base 5 of p, I want to use that in the expression in some way. Okay, so find a way to use log base 5 of p in every question. Well, what this is 5 times log base 5 of p. So that's not terrible. 5 times, well, we know that's 12, so that whole thing has a value of 60. Okay, so again, log base 5 of p is still 12. Now I want to use it here as well. So I want to find a way to be able to use this expression. So see how I have a log base 5 and a p? I just have to separate those apart to get at the p. So log base 5 of 5 plus log base 5 of p. So I can break that apart because 5p, when I have a number beside a variable, is really 5 times p. And when I multiply my arguments, I can separate them by adding my logs. Okay, so this is that matching law. Log base 5 of 5 is 1 plus log base 5 of p. Well, we know from the original question that's just 12. And 1 plus 12 is 13. Okay, let's try another one. So again, I want to find a way to use log base 5 of p. Okay, so I can see there's my log base 5, there's my p, but again, I have to separate them to get at that. So I have arguments that are multiplied, which I will separate by adding the logs. Okay, then what I'm going to do is evaluate this. Log base 5 of 25. I ask myself, 5 to what exponent gives me 25? Well, 5 squared gives me 25, so the value is 2. I bring the 3 down, and this is 3 log base 5 of p. So this is 2 plus 3 times log base 5 of p. That's just 12. So I have 2 plus 3 times 12 is 36. Add those together and I get 38. Okay, so I want you to remember on that last one that we did that the exponent of the 3 only applies to the argument. It doesn't apply to the whole log. Now, that being said, if I have this type of a question, I cannot bring the 3 down. It is not equal to 3 times log base 5 of p. The only time you can bring an exponent down is if the exponent is applied to the argument. So log base 5 of p cubed, because the 3 is applied only to the argument, then I can bring it down. That's okay. Okay, let's try another one here. Log base 2 of x equals a. So based on that fact, I want to use laws of logs to show that log base 2 of 32x squared is the same as 5 plus 2a. Okay, so what I want to do is I want to find a way that I can use log base 2 of x. So you can see in my argument there, I do have an x. I just have to break apart my argument to get at it. So this will be the same as log base 2 of 32 plus log base 2 of x squared. So this is just a number. 2 to what exponent gives me 32? Well, I know that 2 exponent 5 gives me 32, so that log has a value of 5. The exponent of the argument comes down and multiplies by the log. Well, I know that log base 2 of x is the same as a. So this is the same as 5 plus 2 times a, and I have therefore proved. So to summarize, when you simplify logs, you're making them simpler, you're compacting them. Numbers in front go up, adding becomes multiplying. Subtracting logs are combined by dividing the arguments. When you expand, you're making it bigger. So exponents of the arguments go down in front. Exponents that are multiplied, arguments that are multiplied are expanded by adding the logs, and arguments that are divided are expanded by subtracting the logs. So just remember that simplifying makes it smaller, you're trying to compact it, while expanding makes it bigger. So my question for you is, what do cows most like to read? Any ideas? Got an idea in your head? They like to read catalogs. You got to admit that one's really good. Okay, so you guys can work on your assignment, which is 1 to 12, and that concludes 5.5. So the next video that I'll do is 5.6. We'll see you next one.